everybody. We are in week 10 and we are going to do differentiation today. So, what are the learning outcomes? By the end of this week, you should be able to find the gradient of a curve. You should be able to calculate the gradient of a curve using tangent to the curve. You should be able to define the process of differentiation. You should be able to calculate the rate of change using differentiation. You should be good at recognizing an increasing or decreasing function. You should be able to find the equation of the straight line or the tangent to the curve at a given point and find the equation of the normal. Okay, that's what you should be good at by the end of this week, yeah? Okay, so let's start with our straight line, the straight line equation, which we have seen in week 5. And we have seen this example of the height chart of a child from birth to 10 years old. Yes. As you can see, as the x increases, the x value increases, y value is increasing. It's a linear relation. Yes. And the height of the child is along the y-axis and the age is along the x-axis. Yeah. You know why? Yeah. Dependent variables and independent variables. Yeah. So independent variables are on the x-axis and dependent variables are on the y-axis. Yes. So the height depends on the age. So as the child grows older and older, his height increases. Yeah. So each chart helps you to interpret something. Yeah. You get some information from the graph. You get some information from the graph. And here what you get is, what relationship is this? It's a linear relationship. As the age of the child increases, the height of the child increases. It's a linear relationship, yes? And this linear relationship is seen as a straight line. And you have seen that on a straight line, the slope is constant, isn't it? And what is the slope given by? The slope is given by m is equal to y2 minus y1, yeah? The difference between the y direction over the x direction, yeah? Change in y-axis by change in x-axis, yeah? And the straight line equation is given by y is equal to mx plus c. That's the general equation, isn't it? So you can find the value, if you are given a straight line, you can find the value of the gradient. You can find the value of the y-intercept, that is the point where the straight line crosses the y-axis. So what is c here? 60. So you can find the y-intercept c and the slope. And we know how to do that. And we found that the slope was constant, was equal to 10. At any point on the line, you try to find the slope, it is going to be 10. That is, the gradient or the slope is constant all through the line, yeah? At every point on the line, the gradient is constant. It is constant. It does not vary. It does not change. So that's what we have seen for a straight line. And we know how to interpret the gradient, yeah? The gradient is nothing but, in this example, change of height over time. Or you can say that it is nothing but, the gradient is nothing but the rate of change of height with time. It is nothing but rate of change of height with time. Yeah, that's what you've seen, isn't it? With time. Yeah. So the equation of the straight line will be y is equal to, substitute for m in the general equation, substitute for the y-intercept in the general equation, you get y is equal to 10x plus 60. That's the equation of this straight line. So we can say, in general, for a straight line, y is equal to mx plus c, the gradient or slope of the line m is constant along the entire length of the line. And this helps us to interpret the line. It helps us to explain how y changes with respect to x. How any value on the y axis changes with respect to x. Okay, that's what we know about straight line. Okay, what about a curve? What is the gradient of a curve? That's what we're going to see today. Yeah, what is the gradient of a curve? Is the gradient of the curve constant? For example, if you have a curve, x-axis, and you have y-axis, and you have a curve, is the gradient of the curve constant at every point on the curve? Is it constant, or is it going to change? Is it going to vary? How are you going to determine this gradient at every point? The best way is to draw a tangent at that point. Yeah, is the best way is to draw a tangent. What is a tangent? It's a line, it's a straight line which touches the point on that curve. Yeah, it touches only at one point. If it is, yeah, so you can find the tangent. That's not a nice picture. Yeah, I am a very good artist, as I said before, but it's not working here. Let me do it again. Yeah, so you have x-axis, you have y-axis. So if you have a curve, slope at any point on this curve is given by drawing a tangent to the curve. You draw a tangent to the curve. You know this is your tangent T. You know how to find the slope of this tangent because it's a straight line. Yeah. So for this straight line or for this tangent, the slope is going to be constant. Anywhere you find the slope, it's going to be, anywhere you find the slope, it's going to be constant. The slope of this tangent is constant. So to find the tangent at this point on the curve, to find the gradient at this point of the curve, find the slope or gradient for this tangent, and that's going to be the gradient for that point on the curve. Okay, so if you want to find the tangent for this point, for example, what will you do? If you want to find the tangent for this point, what will you do? You will draw a tangent at this point. You will draw a tangent at this point and then find the slope of this tangent anywhere. It's going to be same wherever you find the gradient. Yeah, find the gradient of that line and that gradient. Let's say this is M3. This is M3 and this is M0. Okay. So M3, this gradient of this tangent will be the gradient of this point. So at this point, the gradient is M3. At this point, the gradient is M0. So it's different. So the gradient is different at different point. Okay. The gradient of the curve varies with the curve. So let me show it again with a nice picture. So that's how, if you have a curve and you draw a tangent at this point and this point and this point, that is, let me name the points. You're going to draw a tangent at C, N, and U. And let's say the tangent at C is AB, and the tangent at N is LM, and the tangent at U is ST. Okay? So all these tangent, to find this gradient at the point C on the curve, you just find the gradient for this line and say, the gradient of this line M is M1. So the gradient at this point is M1. The gradient of LM, the line LM is M2. So the gradient at this point N is M2. The gradient of ST is M3. So the gradient of the point U is M3. That's it. So to find a gradient at a point on the curve, just draw a tangent to the point and then find the gradient of that line and then say that's the gradient of that point. Okay, so the gradient of a curve changes as we move along the curve, and we can define that The gradient of a curve at any point is defined as the gradient of the tangent or the straight line drawn to the curve at that point. Okay, so it's very important that you're able to define what it is. Okay, so please practice this and try to understand and see if you can explain it to your friend or your classmate. Yeah, okay, so let's see now. We know how to find the gradient of a curve. Let's see how to calculate the gradient of a curve using the tangent to the curve. Okay, okay. So let's take an example. Let's say we have a function f of x is equal to x squared. The function of the curve is x squared. That is y is equal to x squared. Yeah, it's the same either way. So you have y-axis and you have your x-axis. And the question is to find the tangent at the, or the gradient, sorry, to find the gradient at the point 2, 4. So you go along 2 and 4. So that's your point 2, 4. So how are you going to find the gradient at this point? By drawing a tangent at that point and then finding the slope of that tangent. So for the point 2, 4, it's going to be 4 over 1. Yeah. So the m for this point is going to be, let's say it is m a. Yeah, ma is going to be 4 over 1. So the gradient is going to be 1. Yeah. Now let me take another point. Let's take the point. So for this, it's going to be, gradient is going to be 4. What about the point 1, 1? That is here. So this is the pink line, okay? So if I draw a pink line, that is 1, 1, I have to find the gradient for this line. So this is around, if I drop down, so it's going to be 5 over 2.5. Yeah, 5 over 2.5. That is nothing but 2, isn't it? So the gradient is going to be 2 for this point, isn't it? Yes, the gradient is going to be 2. So you can see that as you go up, the gradient is increasing. Yeah, it's not same. Yeah, the gradient is increasing. It's an increasing curve. The gradient is increasing. Yeah. So let's take the last point, another 3, 9. Yeah, one more point. You can take as many points as you want and find the gradient at each point, and you will still see the relation for the increasing curve. Yeah, but when you go down, it's different, and when you go up, it's different. Because when you go down, it's decreasing, then it's increasing. So let's take the point 3, 9 now. Okay. Okay. So for the same function, what you have to do is draw a tangent at the point 3, 9. So this is your point 3, 9. You draw a tangent, then find the slope of this tangent. What is it going to be? It is 6 over 1, because here m is equal to 6 over 1, or 6 by 1. Oh, what a beautiful relation you can see. As x increases, gradient increases by 2 times x. 2 times 1 is 2. 2 times 2 is 4. 2 times x. Can you see the relationship here? The gradient is, you can actually prove this, but you don't have to prove that in this course. You just have, you should be able to find the gradient. That's all you have to do. Okay. So how are you going to find the gradient at any point on the curve? We just draw the tangent and then find the gradient of the tangent, or you can call the tangent as a straight line because it's a straight line, and just say that the gradient of the tangent is the gradient of the curve of the point on that curve. Yeah. So if f of x is equal to x squared, the gradient is equal to 2x. And this is a gradient function. This is known as gradient function. Okay. So try to be familiar with this term, gradient function. Okay, so we know how to find the gradient of a curve. We know how to calculate the gradient of a curve using the tangent to the curve. Now let's see the main term, differentiation, for this topic. Yeah, my favorite topic actually. I just love calculus because you can have different application for this. Yeah, you can apply differentiation for different. That we're going to discuss all about it in the seminar. Okay, gradient of a curve. Let's take the curve y is equal to, let's take a general equation for a curve. Y is equal to ax to the power of n. Then we can find the gradient of the tangent to the curve at that point x comma y. In this case, I'm just taking a point x comma y, giving it a name. And if we have a function y is equal to ax to the power of n, the gradient is given by the formula n times ax to the power of n minus 1. You don't have to prove this, but if you're interested, we can do it in seminar, and I can put it on the discussion board too. Okay. So if y is equal to a times x to the power of n, then the gradient is given by the formula n times a times x to the power of n minus 1. Okay, you should remember this, guys. Yeah. So n here is it can be negative, a fraction, or a decimal. Negative, you know why it is negative. If n is negative, for example, if x to the power of minus 1, if it is like this, n is negative, it means nothing but 1 over x. Or if you have 1 over x, you can write it as x to the power of minus 1. Similarly, if n is a fraction, that is, you have x to the power of half, then you write it as root of x, isn't it? But for differentiation, if you have something like this, try to write it in this form, fraction form. It will make your life easy. Just like this, if you have 1 over x, please write it as x to the power of minus 1, and then find the gradient. If you have something like root x, remember, root is nothing but a fractional power, a power in the fraction form. So just convert it into x to the power of half. If you have something like 0.5, what you do is usually write it as x to the power of half, isn't it? So if you have something like this, you can keep it like that or like this and solve it. The best way to is to keep it in the half form, yeah? Because it's easy to find n minus 1 if it is in the fraction form, yeah? It's up to you, that one, yeah? But do not give it as decimals, okay? Just convert it into fraction, but they're both same. It is just the simplicity by which you can solve a problem. The gradient of a curve at a given point is equal to the gradient of the tangent to the curve at that point. You know that now. We have seen it just now. Therefore, the gradient of the curve for a curve y is equal to a times x to the power of n at any point on the curve is n times a times x to the power of n minus 1. And the gradient of the tangent at that point is also the same. Okay, so this formula you should remember. Okay, now let me go to the general formula. Yeah, the gradient is usually given by the gradient function. Yeah, for y is equal to this, for y is equal to ax to the power of n, you use the gradient function dy by dx. That's your gradient function. You can either call it as gradient, which is nothing but, for a straight line it is m, for the tangent it is m. M is equal to dy by dx at any point on the curve. Yeah, so it varies for every point. You should remember that. Yeah, so dy by dx. So this dy by dx is a notation we use for the gradient function. Very important point. Please become familiar with these terms. y is equal to, for example, if I have a function or a curve or an equation, y is equal to 2 times x to the power of 3, then here a is nothing but 2, yeah, and the power is n is 3. So what will be dy by dx? You have to just substitute. Dy by dx will be n is 3. So 3 times a is 2, x to the power of 3 minus 1. You just have to substitute that in the formula. Okay, that's how you do the differentiation process. This is called the process of differentiation. Yeah, so dy by dx is nothing but n times a times x to the power of n minus 1. So 2 times 3 times x to the power of 3 minus 1. When you simplify it, and this gives you dy by dx is equal to 6x squared. So you have found the gradient at any point on the curve. Actually, this is a general equation for the gradient for this particular curve. Yeah. So if you want to find the gradient at any point on the curve, just substitute the value of x at that point, and you will get the gradient at that point. So if you want to find, if you have a curve and you want to find the gradient at x is equal to 2 on that curve, then you just substitute the gradient at that point is nothing but 2 times 2 is 4, so it is 24. So that's all. It's as simple as that. Yeah. So you just substitute the point there, only the x value, because in this case there's only x here. Yeah. So dy by dx is the gradient of the original curve or the gradient of the tangent to the curve at any point on the curve. Okay, guys? Okay, now we have special cases. In mathematics, you have general equation and then you have special cases. Let's take the first special case. Y is equal to a times x, where n is equal to 1. Yeah, that is our special case here. Yeah. So here it's simply, if there is nothing to the power, if it's not written, that means it is 1. Yeah. So a times x to the power of 1. So you use the formula dy by dx is equal to a n a x to the power of n minus 1. So n is 1 because n is 1. So it becomes 1 times a to the power of 1 minus 1. So you just get a. You just get what the coefficient of x is. Yeah. So what is the second case? What about y is equal to a? When you do not have, if you do not have the x term, this simply means it is x to the power of 0. Okay. So you can write it as x to the power of 0 and then use the formula n a x to the power of n minus 1 because n is 0 here. So these are the two special cases. N is equal to 1 and n is equal to 0. So you should know these two special cases. So differentiation of a constant is 0. Okay, guys? These are the two special cases which you should be able to recognize and use it to solve problems. So it will be a part of a problem, okay? It will be somewhere, it will be one of the steps in your problem. So you should be able to recognize that differentiation of a constant is 0. So you just write it down, yeah? Okay, so let's go back to a straight line. What we have seen, like for example, in this case, I want to explain to you what is a rate. Okay, okay, what is rate? That is when a quantity changes with time. Yeah? So for example, you have on the y-axis distance and on the x-axis time. So that means here the distance is varying with time. As time increases, the distance increases, or distance over time is nothing but speed. That's what I'm trying to show here. Yeah, it's a simple example. Yeah. So it is m is nothing but change of distance with time, or m is nothing but rate of change of distance with time. Yeah. So you should be able to interpret this as we have seen it in our week 5. But now we are going to see how to write this gradient in for curve. That's what we haven't seen for straight line too. Yeah. So this is the same thing. So I can say that dy by dx is equal to m, and that's equal to speed. It's the same thing. Yeah. Dy by dx is nothing but change in y or with respect to change in x. Yeah. Or nothing but rate of change of a quantity with respect to time in this case. Yeah. Okay, so you should be familiar with this, okay, and relate these two. Yeah. Okay, now another important point. If f of x is a function, the gradient of the tangent to a curve at any point can be known in different names. Okay, some textbooks say that it's a gradient of the function, some textbooks say it is the first derivative, some of the textbooks use the word f prime x, use this, or dy by dx, or first differential of the function, or rate of change of the function. Yeah, we can say it in any way. So please be familiar with all these different ways of saying, because you can say it in different ways. Okay, now let me go to the next topic. Oops, am I stuck here? Yeah. So in general, if f of x is given by y is equal to a times x to the power of n, then f slash x or f prime x is given by dy by dx is equal to n times a times x to the power of n minus 1. That is your formula. I know most of you like formulas. So there you go, guys. There is your formula for differentiation. Okay, so that is your equation of a curve. And this is your gradient function, or the gradient or the slope at any point for the curve, because for curve, the gradient varies, yeah, changes at every point. Okay, so let's summarize before we move to the next topic. The process of finding the gradient function of y is called differentiation. The gradient function is called the derivative. And this branch of mathematics is known as calculus. And because we are doing differentiation here, it's differential calculus. Yeah, we have integration too, but I don't think you have that in your this semester. Yeah, so it's differential calculus. Yeah, it's called. So differentiation, we're going to just go through 4 different forms of problems. Yeah, I'm just going to give you some tips how to solve differentiation problems in when you can see these problems in different ways, but the easiest way to solve them. Yeah. So first form is, we can, if you have the function which is in this form, like addition, yeah, that is what a term is added to another term, and then added to another term, and then added to another term. So the process of differentiation to the functions of this form, how do you do that? You just differentiate each term using the formula. Yeah, so you first differentiate this term plus this term plus this term plus this term. That's how you do it. So here we have a, b, c, and d are constants, as you can see. So how do you do this? By differentiating each term individually to give the gradient function. Okay, so how do you write the gradient function? You write the gradient function as dy by dx, or dy over dx. So write the gradient function dy by dx and then find the solution. Okay, one important thing, before you start doing that, try to bring all the power in the form x to the power of n. N can be negative, n can be negative, n can be a fraction, whatever it is, fraction like this. Whatever it is, try to bring it in this form before you proceed. So here you don't have to do anything, just write it down ax square. Here you should write it as a fraction, but then it's in the denominator. So you will have something like that, b over x to the power of half. But please don't leave it here. Bring it to the numerator and use the negative power. So you have here, it's a beautiful example. You have a fraction and a negative. So n is negative and a fraction. So please try to bring it in this form and then differentiate. Otherwise, you can do it otherwise, but it is possible that you can make mistake. Yeah. So try to bring all those in the negative form or fraction form. That is, keep the denominator free. Okay. And then you have this in this form. See, I've written 1 here, and there is no x term at all here. So I've written x to the power of 0 to make my life easy. That's it, just to avoid mistakes. And then you find dy by dx. Okay. So please pause the video and try to do this in your notebook. Yeah. So the constant term c of x differentiates to 0, and the constant term d differentiates to 0 because differentiation of a constant term is 0. Okay, remember that. Yeah, that's our special case. These two are our special cases. Yeah, so we are using it here. Yeah, as you can see. Now the second example, which you should be familiar and it should come out easily for you, is when you have something like this division or product. Yeah, here it is division, x squared plus 2 root of x over x. Here what you should do is you should bring this to this form. Okay, let me just clear this out. Yeah, so you should bring it to this form, that is individual terms, so that you can differentiate individually, each term individually. So how will you bring this to individual term plus term plus term? So how are you going to bring that step here? So what you have to do is you need to simplify by separating it into individual terms using the common denominator, which we have done in week 3. We know how to do that, yeah? So you divide x squared by x plus 2 root x by x. So you have now individual term. Look at that, how beautiful it is. You have one term, you have second term. Now you can differentiate, but then try to bring, as we have seen, that try to bring to this form. Do not differentiate until you have brought it in this form, all x to the power of n form. So now simplify it. Now you have, is it finished? No, you still have to bring this to the numerator, root of x to the numerator. And then now you can differentiate because everything is like in the form of x to the power of n. Here it is x to the power of 1. Here it is x to the power of minus half. And they are individual terms. So you can differentiate each term. Differentiate this first plus this to get the gradient function. So differentiate term by term to give the gradient function. And so you get this. So that's how you solve something which you have it in this form. How about when they are multiplied, product form? That's our next example, yeah? Or products or powers, something like that, yeah? Something like this, you have to, when you see a bracket, what do? Get rid of the bracket, remove the bracket, get rid of the bracket, remove the bracket. Simplify it, yeah? So you expand it, then remove the bracket because you have a power here. If you have a power, expand the bracket, yeah? Expand it and bring it to this form. Now each term, you have individual terms. See, that is the whole idea, to bring individual terms. Each term is the form x to the power of n, x to the power of n, x to the power of n, all added up. Yes, all added up. So there is a constant here, there is a constant here, there is a constant b and c. Now you can differentiate and find the gradient function by differentiating term by term. Okay, so this is how you do it, yeah? So pause the video and do the problem, please, yeah? Okay, now the last one, differentiating the exponential function. This is very funny, isn't it? It's very straightforward, okay? Y is equal to, it's not funny actually, it's interesting. Y is equal to e to the power of x. This function has the unique property that its gradient at any point on the curve is equal to the value of the function itself. That's the most interesting fact about the exponential function, yeah? And you can actually prove it. Yeah, so let's take an example. We're not going to prove it here, but let's take an example. X is equal to 3. So that means y is equal to e to the power of 3 for this function, okay? So that is nothing but 20.08, okay? Okay, so if I try to find the gradient here, gradient, you can draw this curve using Desmos and try it yourself. And if I try to find the gradient by finding the rise and the step, as we did in week 5, you will see that the gradient is 20.08. It's the same as the function. The both are same. Gradient and the function are same. So what does it mean? If y is equal to e power x, then dy by dx is also equal to e power x. Interesting, isn't it? They both are same. That is why I have stated it here. The function, this function has a unique property that its gradient at any point on the curve is equal to the value of the function at the point. Okay, guys? So for exponential function, we can say in general, if you have a as a coefficient of e to the power of kx, and k and a are constant here, then dy by dx is nothing but the coefficient of x is k here, k times a times e to the power of kx. That's it. So you write this exponential term exactly like that, a exactly like that, but you multiply it with k, the coefficient of x. That's it. So you should remember this, okay? Okay, so the coefficient of the power x in the exponential simply becomes the coefficient of the base now. So the coefficient of x becomes the coefficient of the base e. It's a beautiful relation, yeah? That's it, yeah? Okay, so we have seen all this. Now we've seen the gradient, how to calculate the gradient, what is differentiation, and how to calculate rate of change. It's nothing but dy by dx. Now you have to recognize an increasing or decreasing function. How are you going to do that? Okay, let's take a simple example. A function is increasing when the first derivative dy by dx is greater than 0 at any point on that side. And a function is decreasing when f prime x is less than 0. That is, if I take the curve for this equation or this function, at any point here on this side of the curve or this side of the curve, what's happening? Is the function increasing or decreasing? It's increasing because you find dy by dx for this. That is your homework, guys. Find dy by dx and give me one point where the curve is increasing, that is the function is increasing, and give me one point where it is decreasing by looking at this condition. Okay, so that is your homework. Okay. Now you have to find the equation of a straight line tangent to the curve at a given point. How are you going to do that? You're just going to use the understanding of equation of straight line, which you did in week 5. So to do that, for example, for this particular curve, to find the equation of the tangent at x is equal to 3, you just draw a tangent at that point, find the slope of this tangent, and then you say that that is the slope of that point on the curve. And then find the value of the y-intercept, and then find the equation of the line, yeah? Okay, so first step, differentiate and find the gradient at that point. You have the equation of the function, so you get dy by dx. This is nothing but equal to the slope of the straight line, isn't it? It should be same. So at x is equal to 3, substitute x is equal to 3 here, and then you'll get the point. So it will be nothing but 3 times 3 is 9, minus 4 times 3 is 12, minus 3, which is nothing but 12. So you get the gradient at that point. Now we need to find the equation of the straight line. For that, you have to find the value of y. So you put 3 in this equation. So you at x is equal to 3, what is y? We need to find the value of y. So that is nothing but 3 cube minus 2 times 3 minus 3 times 3 plus 15. And so this is going to be 27 minus, oh yeah, so it's going to be 15, isn't it? It's going to be 15, yeah. So you get the equation of the tangent, because you have to use the general, because it's a straight line. What is the general form? Y is equal to mx plus c. So you know the gradient at that point for this curve. If that is 12, that means at this point, at x is equal to 3, if it is 12, if I draw a tangent at x is equal to 3, at x is equal to 3, yeah, if I draw a tangent at x is equal to 3, if that point has a gradient 12, then any point on this line will also have 12, so mx. Now I have to put the point 3 and 15. So when x, to find c, remember when we did the straight line equation, to find c for this line, y-intercept for this line, you have to substitute the both and then find the value of, okay, oops, find the value of c, which is minus 21, yeah. Okay, so the equation of the straight line is going to be, it's going to be y is equal to 12x minus 21. Okay, that's good, yeah. Now let's find the equation of the normal. Okay, what is a normal? Before we do this, we need to know what is a normal. Okay, so find the equation of the normal at x is equal to 1 for this curve. So that normal means any line perpendicular to that line at that point. So you just draw a perpendicular line there, yeah. So now you have to find the equation of that normal. Okay, so that is your tangent. The normal is a line which is perpendicular to the tangent, and that's your normal. Okay, and that means our question is, what is the equation of this normal? This is what we have to find. Okay, so here we need to remember one condition. When two lines, for example, when the tangent and normal are perpendicular to each other, here these are the two lines we have, the product of their gradients are -1. So if we have, that is, if we have the tangent, if we have the gradient of the tangent to be m1 and the gradient of the normal is m2, then the product of their gradient, that is m1 times m2, will be -1. That's what it says. So this is the condition you should remember. Okay, to find the equation of the normal, you have to use this condition. That is the condition for perpendicular lines. You have to use this, yeah, to find the gradient of the normal. Okay, so let's do that now, yeah, for this question. So you know that we can find m2, the slope, because we know how to find the slope of the tangent. Yeah, so first let's find the slope of the tangent. So first differentiate the gradient at this point. Yeah, and then substitute the point x is equal to 1 there and find that. So you put 3 minus 10, because 10 times 1 is 10, minus 2, which is nothing but minus 9. So that is the gradient of the tangent. Now, how will you find the gradient of the normal? Use the perpendicular line condition. Yeah, two lines are perpendicular, then M1, M2. So just use that and find the value of the gradient of the normal. Now substitute in the general equation. Okay, you know the gradient. Now substitute in the general equation. Now how will you find C? Substitute this point x is equal to 1. And how will you find the y value for this? What is the y value? That's the question here. If x is equal to 1, how will you find the C? What is the value of y and what is the value of C? Good, that's right. To find C, substitute x is equal to 1 and y is equal to 4. In y is equal to this equation here. And then you can rearrange it after substitution and you will get C is equal to 35 over 9 and then put it in your equation. Yeah, put C there. That's your equation for the normal. That's it. So that's all for today, guys. We have seen how to find the gradient of a curve. We have seen how to calculate the gradient of the curve by using the tangent to the curve. We know what is differentiation now. We can calculate the rate of change and recognize an increasing or decreasing function. Good at finding the equation of the tangent and the normal. Yes. So the rest we're going to see in the seminar. We're going to do more problems on each of these topics and try to see how and where we can apply this. Good, excellent.